Hello students, today we will be going over box and whisker plots and describe distribution, completing relationships. This is 9.1 part 2 and I'm going to re-explain some things. Now, this is graph 1 and graph 2 on page 162 of your blue packet. Now let me explain the box and whisker plot. Now this is all of your data. 25% is here. 25% of your data is within this range, 25% is within here, and 25% is here. So know that 50% of your data is the box. 25% here is over here, and 25% is over there. So there's 100% of your data for graph 1. Now, this is 100% of your data for graph 2, where you have 25%, 50%, 25%. Now, know that 25% of graph 1 is here, 25% of graph 1 is there. 25% of graph 2 is here, 25% of graph 2 is there. So again, 50% of the data is the box. So we want to describe the distribution. Now, we want to look at the box. If we have 25% here and 25% here, these numbers are more spread out. Okay, so these are more compact, so there's a lot more numbers in this area, less in that area. So you can think of it, look at the middle line, the median. If there's more room on this side, then it's skewed that way. If it's about in the middle, they're going to be symmetrical. And if there's more room on the left side, then it's skewed left because you'll have more data in a smaller part of the box. And I hope that makes sense. You may need to listen to it again. So we're going to describe the distribution. Right here, we have more data in less area. This is wider. Another way you can think about it is which side of the box is wider, and that will be skewed that direction. So this is wider here, so graph 1 is going to be skewed right. Now, when I look at graph 2, they're about even. If the median, this represents the middle of the data, is in the middle of the box, then we know it's symmetric. Okay, symmetric, okay? Now we need to complete the relationship. This is the mean or the average. Is the average number less than, greater than, or equal to the median? Now I'm going to jump to the symmetric first, because in symmetric graphs, the mean is always about equal to the median. Okay, and you do like an equal sign but curved, okay? Now, we look at the other one, the mean compared to the median here. So our mean, if it's skewed right, is going to be greater than the median. So here's the median right here on graph 1. So the mean is going to be greater than that. So it'll be probably in here. So think about where the larger part of the box is, and that's where the mean will be. And the median, you can see the median here, the mean is greater than the median there, okay? Now we look at our median from median 1, and again, I drew the mean in there. Let me take that out. The median 1 compared to median 2. So the median is this line in the box that's separating the data in half. Again, 50% of the data here, 50% of the data there. Okay, so which one's bigger, this line or this line? Well, this line is around 6, and this line is around 11. So our graph 2 is going to be bigger than our graph 1. So we say that median 1 is going to be less than median 2. Okay, the next is this weird symbol. Again, it's sigma 1 and sigma 2. And that just means how spread out is the data on 1 compared to 2. And the main thing you want to look at is the size of the box. Which one is spread out more? This one has this wide, and then this one is even wider. So this standard deviation is bigger than this standard deviation. So we say standard deviation of graph 1 is less than standard deviation of graph 2. And there you have it. Okay. Now I'm also going to go over the histogram. So again, those are box and whisker plots. Now, some students said that they did not know what a histogram was. Okay. Or on the starter, when you had to draw a histogram, they had no clue how to do it. Okay. So what you need to do on your histogram is you put values down here. And then over on the side, you're going to put the frequency of those values. And I'm going to abbreviate that frequency like that. So frequency and values. Now, in general, you usually have a range of values. For example, on this graph, and I think they do it sideways, 1 to 5. So they have 1 to 5 there. And then they have 6 to 10 here. And then they have 11 to 15 and so forth. I'm not going to take the time to draw that out. It's on your paper. So just know that these are histograms. Again, you have the values here and you have the frequency of those values. And if I had like 1 to 5, there were 10 of them in 1 to 5, then that should be all shaded in. Okay. And it is all shaded in. So we're going to describe the distribution. So I go ahead and I draw like my ends of my graph like that. Okay. So again, there's less data on the right. So that is going to be skewed right. Okay. Right here, I can draw this. Okay. And so what's that going to be? Symmetrical. Okay. So if it's skewed right, we know that the mean is greater than the median. Okay. Because the median will happen probably somewhere over here for the median. And then the mean, because you're adding them all up and divided by that, the mean is going to be greater. So the median will be probably around here, median, and then the mean is probably going to be closer to over here. So again, the median is the middle number in the data when it's least to greatest. And the mean is the average where you're adding all the numbers together and dividing by how many numbers there are. Okay. Now, for symmetrical, remember our mean and our median are approximately equal. Okay. Now we want to talk about comparing the graphs and how spread out the data is. Okay. So here we have data clumped together here. But I think I said earlier, if it's symmetrical, they're clumped together, but not necessarily. If you look here, there's a bunch clumped here at one end of the graph and a bunch clumped here at the other end of the graph. So this standard deviation, that's what this is, again, is how spread out is your data. And this one is spread out more than this one is because a bunch are clumped together and then you have some down here. So I'm going to have to say this standard deviation is going to be less than this standard deviation. So I can't say that all symmetrical ones will be less than the other type. It depends on the distribution of the numbers. Okay. All right. I'm going to have you work on the rest of 163 and also give you some more practice from the white packet. But you can do this, students. You rock.